So we're going to start. We are going to, like, today's topic is specific investment decisions. So what is that you're going to deal in this chapter with? Asset replacement. We know that when we run a business activity, we require certain machines. Like we require a machine for production purpose. We want some like vehicles, like delivery vans to deliver our product in the market. And these machine delivery vans, these are having a certain life. Okay, that means whatever you expect the service from them, or whatever the satisfactory usage what you expect from them, is only going to be for a limited period of time. Not, it's not going to be for the entire lifetime, right? Like, let's say a machine or delivery van will be handy for you for 10 years. After that, these are not going to give you proper service. Again, you have to spend a lot of money for repair, maintenance, servicing, etc. So it is better that you replace this machine. Okay, that means you remove this and bring a new one. Point number two. So for that, you are going to learn two methods: equivalent annual cost and equivalent annual benefit. Second one is lease versus buy. That means whether it is better to lease a property or buy the property. For that, you're going to use NPV method and decide on that basis as well. Then capital rationing. Yes, definitely businesses have limited capital. They don't have, sometimes they may not have adequate money or adequate capital, and they may arrange it. I understand, but always businesses always feel short that they require more funds for future, for certain future goals and objectives, whatever they want to fulfill. They always want, definitely they may have certain financial goals, so they want capital for that reason. And they always feel short of certain money, so they have to use the capital what they have accordingly and smartly. And where it is required, they should use the money very, what we say, like, exactly, specifically they should use the money for that purpose or for that reason. They shouldn't be, that means they should minimize the wastage of funds. Okay, that is what I'm trying to say here. So they have constraints are nothing but bottleneck resource. Constraints mean they have limitation of capital, and they have to accordingly use the money. They should use the money for the maximum benefit, what they can get out of that capital. They should use the money in that manner. Okay, that means they should be using the funds very smartly, or in such a way that they get maximum benefit out of the funds whatever they are spending. They should look for that. So hence here comes hard capital rationing, soft capital rationing, divisible projects, whereby the projects are you can divide your money amongst the projects, and there are certain cases whereby you cannot divide the money amongst projects. You're going to see all these cases. First one, asset replacement decision. So you are going to use the discounted cash flow technique for that purpose, and you're going to use the discounted cash flow technique for asset replacement decision, and you are going to assess how frequently, that means how sooner, frequent in the sense more often, a non-current asset that is in continual use in a business, example they have given delivery van, should be replaced. That means when in how many years they should replace their asset or delivery van in this case, right? If an asset is replaced less frequently, then it has longer replacement cycle. Very, very clearly understood fact. If let's say there are there's a delivery van of Tata company, there's a delivery van of some ABC company. You replace Tata company's delivery van once in 5 years, and you're replacing this in 3 years. Replacement cycle. Shorter replacement cycle, longer replacement cycle. So let's say if you have a longer replacement cycle, I'll be taking Tata. Shorter replacement cycle, I'll be taking ABC. So when you have shorter replacement cycle, your operating costs are less. Why? Because you are spending money for a shorter period of time. High scrap value when the asset is disposed. but increased capital expenditure because again you have to buy asset, right? Reduced capital expenditure because you are buying the asset after, here it is like 3 years, right? Here it is 5 years. So more 2 years you are using the asset and you are then plan to replace it. So your capital expenditure here, you are spending more capital very sooner. You are spending capital like even after, like at a later stage. Like here you have to buy, you have to replace within 3 years. Here you are replacing within 5 years. So more 2 years you are using the asset and again you are spending money for buying, right? Now, but as the asset get older, it may cost more to operate and residual value will be lower. So here the residual value will be higher because you are using the asset for a shorter duration and then you are selling it. Here you are using it for a longer period and then you are selling it. So your scrap value or whatever the scrap value you're going to get or residual value you're going to get will be very less in this case because asset has been used for a longer period of time, right? Now,
So
one more thing there.
Can you explain about lower operating cost?
Here you are using the asset for 3 years. So your operating cost is for 3 years, right? Here you are using for 5 years. So you're going to operate it for more time. So more operating cost.
Yes, sir. Got it.
Did you understand?
Yes, sir.
Yeah. The ideal replacement cycle will minimize the cost per year over the replacement cycle. This is called equivalent annual cost. So ideal replacement cycle is nothing but the time period. That means let's say 1 year or 2 year or 3 year or 4 year, 5 years. You replace your asset every 2 years, let's say. So that is your ideal replacement cycle. That will minimize the cost per year over the replacement cycle. Okay. So yeah, as like, you know, you're going towards the replacement, then again, you're not going to spend money on that asset, right? Right now. So what is the formula for EAC, the equivalent annual cost? First, NPV of costs over the replacement cycle. NPV is present value of cash flows, that is cash inflows, minus present value of cash outflows. So equivalent annual cost is what? You are going to find out the NPV, or let's say they'll not give you that much task to do, even they give you the NPV in the question itself. NPV of costs over the replacement cycle divided by annuity factor for the life of the asset. So let's say the asset is for 5 years, and of course, since it's a DCF technique, they'll be giving you discount factor. Let's say the discount factor is 10%. You have to take annuity factor for that 10% for 5 years. Divide it, you will get the equivalent annual cost, right? Now, any revenue resulting from the use of the asset will be disregarded as this revenue will occur in any case. That means it is irrelevant that that particular asset like, you know, will be giving you definitely the revenues because you're using it, because you bought the asset for usage purpose, right? So any revenue, whatever the revenue you are earning from the usage of asset is not taken into consideration here, because definitely you're going to generate revenue by usage of that asset. That's an understood fact, right? So whatever the replacement cycle and is therefore not a relevant cash flow. Here in this case, it's not a relevant cash flow. Why? Because you bought the asset for that purpose only, right? So because the method is also equivalent annual cost. So we are not regarding cash revenues here. We are not regarding the revenues here because however you are going to use the asset for generating the revenue, right? So what is equivalent annual cost? It expresses the present value of cost of an asset replacement cycle as a cost per year. Present value is nothing but, let's say you want to replace your asset in 2 years, every 2 years. So there are, like, you can consider every 1 year you want to replace, every 2 years you want to replace, every 3 years you want to replace. So equivalent annual cost is nothing but the present value of the cost of an asset replacement cycle. Suppose my asset replacement cycle is in 1 year. So the present value of the cost of the asset replacement cycle. That means what is the present value of the cost in 1 year? if I'm replacing the asset in this 1 year, is what is EAC, equivalent annual cost. For that particular year, let's say I want to replace my asset in 2 years. So EAC is nothing but the equivalent annual cost, is nothing but the present value of the costs from that particular costs like in that particular year which you're going to incur, right? So if I'm going to replace my asset in 2 years, I'm going to find out the present value of all the costs with respect to that second year, right? That is my equivalent annual cost in that replacement cycle. Okay, now asset replacement. So here is a question and I'll show you how to do this, and then I will give you a activity as well to solve. Okay, let's understand this. So let's say a company uses machinery which has the following costs and resale values over the 3-year life per machine. Okay, so if you are using the asset for the first year, these are the costs you're going to incur. Second year, this is the cost. If you're using it for 3 years, this is the cost. The purchase cost of the machine is $25,000 and this is the resale value. If you're selling it in 1 year, you get a higher resale value. Second year, since you're using it for a longer period of time than when compared to first year, lower resale value. And here you're using for the longest period of time, you get the least resale value, right? We have already discussed that in the theory as well. This is the 10% is the cost of capital, which can be used as a discount factor, because you know the formula for EAC is what? NPV by annuity factor, right? Yeah. So now let's go ahead and find out the NPV. So first, these are the the asset is bought on the first date of the project, when you're initiating the project, whatever it is the first and foremost investment what you do. So in 0th period, we have $25,000 investment, right? And the present value is also going to be the same. Why? Because on that day there is no discounting going to happen. This is if you replace your asset every year. The replacement cycle is for 1 year. That means first year only you want to replace your asset. This is again we are going to consider if you want to replace your asset for 2 years, like in 2 years, right? That means every 2 years you want to replace and get a new asset. Here every 3 years you want to replace the asset and want to get a new asset, right? So again the investment is going to be the same here itself, and also the present value is going to be the same and present value is going to be same, right? This of 10% is for the first year, the factor is this, second year factor is this, third year factor is this, right? Now what are we going to do here? We are going to find out the present value of cost over one replacement cycle. So we are going to find out the present value, because that, just a second. Yeah, we are going to find out the present value of cost over one replacement cycle. Okay, so first, what is the cash flow to us in the year 1? Here is given. Running expenses is 7,500 and resale value is 15,000. So I am going to take the running cost. Running cost is this, and the scrap value, that means the resale value at the end of the first replacement cycle will be 15,000. So when we multiply this with the present values, you do the multiplication part, this into this and this into this. Do that in your calculators. Do the calculation simultaneously. You'll get this. Yeah. Same. Yeah. Okay. Now, if you do that in the second year, so here what is happening? This is your cash outflow. This is your outflow. So your present value of cash inflow is this, and your outflow is this. You are going to get negative value. This is your NPV. Fine. NPV is what? Present value of cash inflows, which is this, minus present value of cash outflow, which is this. But since your outflow is more, your inflow is less, you have negative value. If you are going to replace your asset in the year 2, that means the replacement cycle of your asset is going to be 2 years, right? Okay, so if every 2 years you want to replace your asset, Replacement cycle is 2 years. So you're going to consider the first year cash flows as well, because if you want to replace your asset in the second year, the running cost for the first year is what has already been incurred, and the running cost for the second year is also been incurred, right? And also first year, if you would have sold, now you are selling it in the second year, so your resale value is 10,000, right? Now you can see the question. Second year resale value. So that means here you are planning to sell the asset in the first year. Here, if you want to sell your asset in the second year, that means you are using the asset for the first year and also for the second year. So you're going to incur the running cost for the first year, for the second year, and then you're selling it. Okay, all the present values are given and the NPV is found out, still it's a negative value. Okay, now next. Again, if you want to replace your asset in every 3 years, so your running cost for the first year, second year, third year, and again the resale value in the third year, you're going to get a negative NPV as well here, right? Now I want you to just take time to calculate all this. I'm giving you time. Everywhere this value is nothing but the present value. That factors are given. Multiply the factors with the present. This cash flows. You'll get the present values here as you are seeing. 7,500 into 0.909 still this. 11,000 into 0.826 is 9086. Come on, do that. And again 10,000 you're selling in the second year, right? Into 0.826 is going to be this, right? Do them, calculate them. Confirm me when the calculation is done.
Done, sir.
Yeah. Everyone, like, I'm waiting. Okay, now you find out the equivalent annual cost. So the NPV is here divided by the factor. Okay, the first year factor is 0.909. Then NPV is given 32,644 divided by, you have to take annuity factor, that is 0.909 plus 0.826 is going to be 1.736. This is the annuity factor, right? And then again here also you have to take annuity factor, 0.909 plus 0.826 plus 0.751. So when you're going to divide these with the factors, you're going to get the equivalent annual cost. Okay, so the optimum replacement policy is with the lowest equivalent annual cost. Here this is every 3 years, because in the third year the equivalent annual cost has been 17,957, right? So you have to replace your asset every 3 years, in every 3 years, right? Calculate this and finish it off. We'll go for the activity question. So in every 3 years you have to replace your asset.
Done, sir.
Yeah. Yeah, everyone finish. I'm going for the next one. Okay. Solve this question. The activity is in front of you. I'm waiting. Start this. Okay, I'm waiting. See, this is very simple. Same kind of question which we did right now. I want you to do this, right?
So in year two scrap values are given, sir.
Yes, you're doing or you want me to do?
Trying, sir.
Done?
No, sir, doing.
Okay, okay. So, okay, we will discuss this. Let's say it's like, you're going to do that every 1 year, every 2 years, right? So first is time. So we'll take 0, 1. Okay. So, and here we will take 2. So, like the investment done by you is how much? 30,000, right?
30,000.
Yeah, here also it will be 30,000. And discount factors. Discount factor at the rate of 15%.
50.
It's, yeah. So here it's going to be how much is the discount factor? First year it is 1, then 0.870, right? 1 by 1.15 is 0.870, and second year the discount factor is 0.756. You can do that and see. So what's going to be the cost in the first year? It's going to be
3,000.
scrap, running cost of 3,000 and scrap value of 10,000 in the first year, right? So in the first year, the running cost is 3,000.
3,000.
And like the scrap is 10,000, right? This is the running cost, this is scrap. So it is going to be 7,000, right? So 7,000 into 0.870 is how much? The discount factor.
6090.
6090.
90.
So 30,000 is the negative value and the positive is 6090. So what you're going to get present value? Subtract these two. Yes.
23,910.
So we'll do it for the second year also, right? The second year also, like, you know.
It's negative, no, sir?
Yeah, negative only. Write down negative. Second year, higher running cost 4,000, scrap value. So I'll take net. This positive value, this negative value. So 3,000 I'll take here net. Okay. So how I got is 4,000 is your cost and 7,000 is your inflow. So this will give you 3,000. Okay. This is your, the scrap value is less and the running cost is, in the second year van has higher running cost of 4,000. So this also we are going to take 7,000 of the first year, right? First year it was how much? 7,000, and second year it is how much? 3,000, right? Now you do this. But in second year I'm not going to take the resale value, right? Sorry. Resale value is only for the first year. What is the running cost in the first year? 3,000 is the running cost. And second year I have done the netting. It is 3,000, right? Positive 3,000. Now going to be 30,000 only. 3,000 into 0.870 is going to be 2610, and 3,000 into 0.756 second year, this is going to be 2268. Okay, this is negative, this is positive. Now you find out the present value and tell me. 30,000 plus 2610 minus 2268. I'll do 30,000.
26,732.
Yeah, 30,732, right?
Yeah.
30,000. 30,000 minus 30,000 plus 2610 minus 2268. Okay, 30,342. Okay, and then we are going to do the present values. We have already done the present value. Now equivalent annual cost for the first year 23,910, right? Divided by, what was the factor for the first year? 0.870, correct? Now tell me what's the equivalent annual cost for the first replacement cycle, and equivalent annual cost for the second replacement cycle is going to be 30,342 divided by the annuity factor 0.870 plus 0.756. It's gonna be, if I
So first
calculate
year
1 point,
27,000.
sorry,
So first year
sorry,
27,482.
okay, and here
18,660.
so which one is better?
Second year.
Second replacement cycle, right? Now all of you please make a note of this. If you have not done, you can do this. Any doubts you can ask me right away.
So how did we get this 2610, sir?
See, the second year is only going to be the running cost, right? You're not going to take the resale value. So
Yes.
3000 into 0.870 is 2610, na?
Huh. So can you repeat it again, sir?
Which one?
Like we are not taking here. What will not take?
You
Resale.
are going to take the running cost, right? You are not going to take the resale value of the first replacement cycle.
So 3,000 into 0.756.
Why 0.756, 0.870 first year running cost? There is one negative 3,000, one positive 3,000. Positive 3,000 into 0.756 is this. Aren't you not going to take the running cost of the first year?
Okay.
Hello.
Yes, sir.
See, this running cost is there or not first year?
Yes, sir.
Are you going, if you are going to replace the asset in every 2 years, first year running cost, are you not going to take?
Yes,
Are you
sir.
not going to spend running cost in the first year?
Yes, sir.
That's what the running cost is this. And second year also you're going to spend the running cost, which is 4,000. And also you're going to resell, like sell the asset, you're going to get 7,000. So I did a, like, I directly adjusted them and wrote 3,000 here.
Hmm. Okay, sir.
It was like this. Second, 30,000 is the investment. Second year running, in the second year, the first year running cost is going to be existing. And here I am just writing it in the first year column only. You're not saying this. And first year running cost. God, what is happened? What's happened with this? First year running cost and second year 4,000 is the running cost. Okay. And 7,000 is the resale value. So this two I adjusted and wrote 3,000 positive value. Okay. This has to be discounted at the rate of 8.7. What is that? 0.870. Sorry. This one 0.756. When you multiply these two, you're going to get 2610. And this one, when you're going to multiply, you're going to get 2268. That's what we did. Okay. Hello.
Yes, sir. Got it.
Yeah, this is going to be still negative. This is going to be positive. So 30,000, this, if you add negative value minus this, you get the value and then divide by annuity factors. Okay. You get the equivalent annual
Yeah.
cost. Yeah. Shall we move forward?
So once again, select. Can you scroll it down?
Okay. Okay. You take your time. No problem.
Scroll it down, sir.
Go down.
Ah, yeah, that's. So then it's like 30,000 minus 2610 plus 2268
What, 30,000?
minus 2610 plus 2268.
Y minus this is negative value. This is negative value. They're going to add, not subtract. Correct? Negatives are going to be added, right?
Yes, yes.
30,000.
And even 2268. Yeah.
I'm going to do, wait, 30,000 plus 2610. These are negative values. Minus 2268. 30,342. Finished. I wrote it here. You write this one.
Yes, sir. Done.
Yeah. Others, have you finished? If it is done, then I will move forward because I need to wind up till equivalent annual benefit. Then we can start lease or buy tomorrow. Tomorrow is the last class for this. Okay, done. Tomorrow. Lease and buy and divisible projects. Okay, let's go ahead. As we have done the equivalent annual cost method, assets with different useful lives. So the same technique is also useful for deciding whether, when considering non-current assets that are in continual use within a business. Yeah, this method is good if you are using the asset continuously. It is better to invest in a cheaper asset with a shorter expected life or more expensive asset with a longer expected life. Yes. So see what happens if the asset you are buying at a less cost, it's cheaper and it has short life. That is better. And why? Because you're using it for short span of time. Okay. and you will be kind of, you know, incurring the less operating cost. You'll be getting more resale value, right? So if you buy a lesser cost asset, that is better in for short span. But like if you're using an asset for a longer period of time, it should be very superior one, technically superior one, a good one, you know, which can last for a longer period of time. Okay, that is only possible if you buy, if it's like, you know, expensive asset, right? You take one you just decide one thing, you just consider one thing. You want to buy a AC. Okay, you want to buy a AC. There are two ACs available. One is Voltas, one is O General. O General is available for 1 lakh. Voltas is available for 30,000. Now you tell me, which is a better AC in these two? Come on, I want an answer. Which is a better?
Voltas.
Sorry, Voltas is a better
Voltas.
one.
Like it's cheapness.
Wait, where is it written? Voltas is a better company than O General. O General is a market leader.
I don't know about AC, sir, but I thought by deciding it by price.
Okay, okay, fine, fine, fine. Okay, okay, no problem. Okay, like Voltas is a Indian brand. O General is an international brand. The ACs of O General are the best in the world. I'm not saying Voltas is not good, but you know, this is a cheaper one. Okay, and you can use it as, like, you know, rough and tough, because you know this will not last for a longer period. That means O General can give you service without any maintenance service issues for 10 years. Voltas, like, you know, every year you have to service, and max to max 5 years. So if you are putting, like, if you want, you know, that's what they are saying, it is better to invest in a cheaper asset with a shorter expected life. That means this you can use and you can buy next another one also. That means next after 5 years again you can buy 30,000 asset, and again 5 years 30,000. So however in 10 years you're spending 60,000 only, right? But if you want better service, better quality, more, like, less electricity consumption, a very strong AC, then you go for a costlier one, which is O General, right? It may have a longer expected life and it will be more expensive, but you know, it will be giving a better service than Voltas. Are you understanding now what I'm saying?
Yes.
Like, you know, if you want to buy a pen of a Parker pen of 100 rupees, and you want to buy that 5 rupees pen which we just use and throw, so this one is for a shorter span of time, this one you will be using for longer time, right? So this is expensive. It is better to buy this Parker pen for longer period and this pens for daily usage. Are you understanding now?
Yes, sir.
Will you buy Parker pen for rough and tough use?
No.
That's what. Simple. Again, ideal replacement cycle will minimize the cost per year over the replacement cycle. That is the equivalent annual cost. So you should be seeing what is the ideal like replacement cycle for you. If you choose the ideal replacement cycle, then your cost will be minimized. We have just seen that practically right now. Drawbacks: this approach only focuses on cost and fails to recognize that an asset gets older, there could be problems with reliability or quality as the asset ages, right? Yes. So now there is an exam point. A common error is that students include the scrap value in more than 1 year. That's what I already told Isha. You should take scrap value of the first year in the first replacement cycle, second year's scrap value in the second replacement cycle. Don't take first year scrap value also. That's what they have cautioned here. Now let's go for equivalent annual benefit. Expresses the NPV from a project as an annuity, that is a constant cash flow per year. So what is the equivalent annual benefit formula? NPV of the project by annuity factor. But what is this equivalent annual benefit? This expresses the NPV from a project as an annuity. That means your NPV is going to, like, there will be a constant cash flow. That NPV is shown as a constant cash flow. What is shown as constant cash flow? NPV. Are you understanding?
Yes.
I will explain you that one. project A has an NPV of $8.22 million and an expected life of 6 years. So we will convert this 8.22 into constant cash flows. How? The discount factor is 12%. Annuity factor for 6 years is, like, this is 6 years, right? So for 6 years, the annuity factor is 4.111 at the rate of 12%. I'm saying as the annuity factor at the rate of 12% for 6 years, right, is 4.111. So project A will have an equivalent annual benefit of how much? 8.22 million dollars, which is the NPV divided by the annuity factor. It's going to be 2. That means every year you're going to get $2 million as constant cash flows for 6 years, right? Are you understanding?
Yes, sir.
But this is the present value. That's what I'm saying. This is the present value. That means every year beginning you're going to get this 2 million. At the end of the year it's going to change. Why? Because at the beginning, if the present value is 2 million, the future value is going to be different, right? At the rate of 12%. Please tell me yes or no. Then that will become how much? 8.22, right? Hello.
Can you repeat?
What I'm saying is 8.22 is the NPV, right? Divided by 4.111. So your annual cash is how much? 2, right? But
Yes, sir.
but what you will be thinking is, if it's 2, then for 6 years it should be 12, right? Not the case. Your cash of 2 is at the beginning. At the end of the year it's going to be different, na? How? 2 into 1 plus 0.12. That is 2 into 1.12, correct? Yes or no?
Yes. Yes, sir.
Yeah, so that is the future value. So 2 at the beginning is something else at the end. So end it is how much? For the first, that is only for the first year. It's 2.24 for the first year. Second year it is 2 into 1.12 whole square. It's going to be 2.5088. So like that, if you do for 6 years, you're going to get how much? 12 million, right? Hello.
Yes, sir.
Yeah, but that is just an explanation. What we want is, we are showing NPV as a cash flow. Okay. So an alternative project B you are considering. This was for the project A, whose NPV was this, and annual cash flow it is giving us 2. If you are considering one more project which is 8, which is having an NPV of 8.90 and expected life is 7 years. So you are dividing this particular NPV with the annuity factor. You're getting 1.95, correct? Because 12% for 7 years is 4.564. So which project is better actually in this? The A one, right? Because it's giving you more cash flow, correct? Hello.
Yes, sir.
So we will rank project A, okay, higher than project B, correct? Right? So
Yes, sir.
yeah, NPV, see, A and B. A's NPV is 8.22. B's NPV is 8.90. A's equivalent annual benefit is 2. B's equivalent annual benefit is 1.95. Despite this having higher NPV, this will be ranked higher. Why? Because it is giving more cash flow per year. Correct? That's what. And this method is very important for comparing the projects with unequal lives. That means we took this for 6 years, this for 7 years. Now drawbacks. This approach only makes sense if the projects are being continually renewed. If this is not the case, then the project with the highest NPV would be chosen. That's what. B would be better, right? If that is not the case, if the projects, if they are saying that you are not continually reviewing the project, same like you considered in case of equivalent annual cost. Now lease versus buy, this is what we are going to do tomorrow. We have 2 activities, then capital rationing. Done chapter. Okay, fine, thank you. See you tomorrow in the evening. Tomorrow is the last class for this.
Thank you, sir.
Thank you.